The overall goal of this experiment is to coat nanoparticles, nanopowders, or drug particles with a plasma polymer in order to control the release of the core material. Begin with the preparation of silica nanoparticles or calcium chloride nanopowders for deposition, breaking any agglomerations. Then place the particles in a plasma reactor and coat the nanoparticles by plasma polymerization of isopropanol using plasma-enhanced chemical vapor deposition. Next, to determine the permeability of the deposited shell, dissolve the core materials in a proper solvent while monitoring concentration. Results obtained show the permeability of the core material based on measurements of the ionic conductivity in a suspension of coated particles in water.
The idea for this method came from the film deposition literature. A lot of work has been done on plasma deposition of thin films on flat substrates, but not on particles. So by adapting the coating method to particles, we open up possibilities for new nanomaterials. Visual demonstration of this method is critical as various steps are difficult to learn because they involve working in a low-pressure plasma environment. Anaram Shahravan is a grad student from my laboratory and she will now demonstrate this procedure.
First, wash the dry silica particles with pure ethanol. Leave the sample under a fume hood to evaporate the moisture. Next, sift the particles through a series of metallic meshes in order to break any remaining agglomerations. Transfer the particles